Hello Math 152 students. In this video, we're going to take a look at section 6.2 and try to understand a binomial experiment and how to use StatCrunch to calculate probabilities. So in this case, you want to make sure you read through the initial information very carefully about what a binomial experiment is. Your book gives you several examples and some practice there. I want to go over these criteria with you, and then we'll jump into a specific example. So think about binomial as success or failure, two options. And as long as you can think about making two options out of your scenario, you can treat it like a binomial. For example, when we were thinking about rolling a single die, that in and of itself is not a binomial experiment because we had 6 outcomes, not 2, and we didn't have this clearly defined success and failure. However, if we modified our scenario to say rolling a 4 is success and everything else is failure, like you roll a 4 and win, any other number you don't, you can think about that as a binomial. So for a binomial, you are going to do the experiment repeatedly, like rolling a die and counting 4 as success. And you can talk about how many times you're going to roll the die, the probability of success, the independence of the trial, and the disjoint events. So let's go through this criteria and make sure we understand how it applies in the scenario. So let's say you're going to roll a die 10 times, or 100 times, or 1,000 times. It doesn't matter how many times it is, but you have to know ahead of time. That number of trials is your N. Down here in the second box, they let you know the letters. We'll just kind of go through it together. So the number of trials is your N. You have to have, for criteria 2, your trials is independent. So if you roll a die and pick it up and roll it again, that first roll doesn't impact your second. If you flip a coin, you can think success and failure, heads or tails, and one flip doesn't impact the next. Then you have to have 2 mutually exclusive outcomes. So you roll 4 or you don't, heads or tails. Your success and failure can't overlap. And then number 4, you have to have a probability of success that's identical for every trial. Meaning, the probability of rolling a 4 for a fair die is always 1 out of 6. Or the probability of rolling heads is 0.5 every time that you do it. That probability is referred to as your P. So your probability of success is P, and then since there is success and failure, the complement, or the 1 minus P, is the probability of failure. So then we're incorporating the idea of the random variables and those X's as out of 10 trials, you could have, for the coin flip, you could have 5 heads, 6 heads, 7 heads, but you could also have 0, 1, 2, 3. So if you're doing 10 trials, your number of heads could be anywhere between 0 and 10. The X would be the number of heads, and the values could range between 0 and your number of trials. Or in the die roll example, you could have no 4s all the way up to 10 4s. So when you're reading through an example, you want to think through these criteria, see if you can identify your N and your P, and make sure you understand what your X is. So let's take a look at the next parts in your book. I would read through this next example, the yellow part, carefully. You're just identifying binomial or not in that. Then for the second example, for computing probabilities, we're going to do this with StatCrunch. Your book goes through an entire example of building a tree diagram, and it goes through some formulas and some really long calculations that I don't recommend that you do. So skip over that one for now. And what I want to do is ignore this formula and show you how to do a StatCrunch problem. So we're going to jump right to example 3. Take a look at this one. So according to the CTIA, 41% of all US households are wireless-only households. In a random sample of 20, what is the probability that, for A, exactly 5 are wireless only? So when we read this example, you already identify a probability or a percent somewhere in the problem, and then they usually give you vocabulary to identify your N, a random sample of 20 households. So your N is 20. Think about each trial. There's 20 trials in this case. We poll 20 households, and each household could be wireless only, success, or not, failure. So we could have 0 successes, 0 wireless only, 1, 2, 3, all the way up to 20 wireless only. Sometimes we might get exactly 5, sometimes fewer than 3, sometimes at least 3, or anything, like any combination in the middle. Oops, so let's go back up there. So instead of doing our probabilities with this formula, we can go to StatCrunch and ask it to build a binomial model for us, display a graph, and do these probabilities. Go into your stat menu and calculators. Instead of custom, choose the binomial option. And don't worry too much first because we have not put in our N and our P. For us, our N is 20 and our P is 0.41. Don't worry about this part right now, just hit compute. So what this shows you is you start at 0 on the x-axis and it goes up through 20, but sometimes it doesn't display the 20 or more up here because your probabilities by the time you get to the extremities are really, really low. Sometimes StatCrunch just cuts it off. Now, what is this doing in here? The probability that we're looking for, you have to enter in this box, and you have 2 options. You can do a standard or between. Standard is the default. The between has 2 parts of your inequality. And whatever you put in here, StatCrunch highlights in red. So let's go back to our ebook and look at that first example. If we want to know the probability that exactly 5 out of those 20 are wireless only, that's an exactly 5 scenario. And we have to go in and select. We don't want a less than 5, we want equal to 5. Then when I hit compute, notice it highlights my red bar and it gives me that probability. So about 6.6%, depending on how many decimals you want to keep. Notice that 6.56%, approximately 6.6%, is exactly what that by hand formula does. Okay? This whole mess goes back to combinations and permutations, which was one of the topics we actually skipped over in Chapter 5. So this idea of 20 choose 5 is something we really didn't discuss much either. So then let's take a look at our other components. It really becomes a matter of making sure you can read the example and understand how to adjust your inequalities or equalities. If we want to know the probability that fewer than 3 are wireless only, that means up to but not including 3. So less than 3, be careful here with your less than and your less than or equal to, because that does make a difference. So fewer than 3 looks like less than 1%, so 0.27%. Be careful here. Either write down your probability as a decimal, or if you turn it into a percentage, you would want to say 0.279%. So let's take a look at what your book does. Notice they list it as a decimal, or they could write 0.28%. So just be careful if it's asking you for the decimal or the percent version. For our third part, part C, at least 3. So think about at least 3 means 3, 4, 5, 6, all the way through 20, or greater than or equal to 3. Okay, so notice at least 3, it highlighted all of this part and up. It's a pretty big probability, 0.997. 0.9972. And then the very last example was between 5 and 7 inclusive. Read carefully because sometimes it's inclusive, other times they can not include those boundaries. But if we want to know between 5 and 7, make sure you change to your between. And then here, the only option for the between is the or equals to. So if it says non-inclusive, you're going to have to adjust those numbers. So notice StatCrunch highlights our 3 bars, 5, 6, and 7, and gives us a probability 0.3381. Double check that with ours. So notice they get the same thing by hand. And I want to talk a little bit about the interpretation. Notice with our StatCrunch, the highest value in here looks like 8, right? So their most frequent option is going to be exactly 8 out of 20. But really, somewhere between 5 through 10, 5 through 11 are pretty frequent. So the chances that we get between 5 and 7, notice that cumulative probability when we sum it up is pretty large. But each of the individual probabilities, notice none of them is particularly large. Even for our highest bar, it looks like that's under 20% if we read over on our x-axis. So let's stop there for this one. And I want to point out one more formula in your book that you do want to be able to do by hand. So your book goes on and also tells you how to use binomial tables. You want to avoid this and do StatCrunch instead of the by hand or the tables. Okay, so you can skip all of that. And the next part that I want you to do, notice your ebook's a little bit hard to navigate here, is the section that says compute the mean and standard deviation of a binomial random variable. There are 2 formulas which you do need to be able to do by hand. StatCrunch doesn't pop these up as part of the distribution that it gives you. And these 2 formulas are for mean and standard deviation. So notice the formula for mean, which is the same concept as expected value, is just your number times your probability. Think back to the example with the wireless. Let's say you surveyed 100 households. So your N is 100, and 41% have wireless only. That means you would expect out of 100, 41% or 41 would have wireless only. But if you had 20 households, you would expect 41% of that 20. So you just multiply 41 times your 20, which is your ID of your N times your P. Then for the standard deviation, you do have to use your N and your P here to do this by hand, but it's a very quick calculation. You're not going to be doing a table and a lot of work to get that. So notice your book does an example. Sorry about that, guys. Your book does an example here with the wireless. So they change it actually to 300 households. If we had 300 households, 41% of that would be 123 we would expect to have wireless. And then notice putting this into our standard deviation calculator, we can turn out our standard deviation. You do want to make sure here in your calculator that your square root goes over all of this, or do your N times P times 1 minus P, and then the square root of that. So just be a little bit careful putting that into your calculator, but you do have to be able to do those 2 by hand. So the last thing your book goes through is creating graphs. And if you're using StatCrunch, StatCrunch is producing a graph for you and then calculating the probabilities. So let's end it there. You really want to get in and do some practice with these ones to make sure you know how to identify the N and the P and work the StatCrunch calculator.